Thank you for the introduction. I'd just like to express my appreciation to the organisers of this conference and say that it's wonderful to be in Sapporo this week. This study was conducted on a very large farm or series of farms in Tasmania that pool their resources to rear the heifers together. So there's 5,000 heifers being reared together. Australian dairy farms are largely pasture-based, and due to the presence of Johne's disease in southern Australia, we have what's known as a Johne's disease calf assurance plan, where calves are removed from their dams and reared separately so that they have a low chance or low risk of exposure to Johne's disease bacteria. This results in calf paddocks being used throughout the year, and often they become heavily contaminated with nematode larvae. Calves on this farm were reared on the one of the 20 farms that make up the complex until they were weaned and brought to the age of about 100 kilos at 3 to 4 months of age. Now, just incidentally, due to the fact that they often carried high worm burdens at this time, they were treated on the farms of origin, usually with macrocyclic lactones, and most of the treatments used were porons and some were injectables. Now, we've previously found resistance to macrocyclic lactones in both Cooperia and Ostertagia in Australia, and the work was done by Steph Bullen and published in the Australian Veterinary Journal. And we have also published research that showed lack of efficacy of macrocyclic lactones against both Cooperia and Ostertagia in feedlot cattle on induction. Calves are typically grown through to when they're 300 kilograms at about 14 months of age, and once they're joined and pregnant, they are sent back to the farm of origin. And it's during this time between the age of weaning and their 300 kilogram target joining weight that the average daily gain is measured by monthly weighings to ensure that these calves are growing at the right rate. And the growth rates are compromised by the presence of high levels of nematodes. Now, this trial was conducted in the southern state of Tasmania, and just for those friends from the Northern Hemisphere, the further south you go in Australia, the colder it gets, and so we're heading down close towards the South Pole there. Not quite as close as New Zealand is to the South Pole, but the temperate conditions and reliable rainfall make the dairy conditions, the cattle raising conditions, very similar to much of New Zealand. Also, it's worth pointing out that in Australia there's no restrictions on the sale of anthelmintics, and so rural stores sell anthelmintics and farmers are able to obtain them without a prescription. The Van Diemen's Land Company owns 20 farms in northwest Tasmania. In fact, if you have a look at the map, you see the name Woolnorth there. That's home to 15 of these farms, and there's another 5 farms just outside the combined Woolnorth farm. Cattle are raised on pasture with very little supplementation, and most of the pasture is improved ryegrass. There's a sandy soil type, and there's a bit of salt carried in from the west coast. The heifer-rearing unit takes calves off all of the farms and inducts them, and grows them. They try to add about 200 kilos to their body weight over the next 9 to 10 months. The Environmental Monitoring Station in northwest Tasmania regularly monitors air and water quality, and it's found to be amongst the most pure water and air in the world, because it's blown across the vast expanse of the Southern Ocean before it makes landfall in northwest Tasmania. Farm rainfall is approximately 1,400 millimetres per year, and you can see that the farm is located on the very northwest tip here. The distribution of the rainfall is fairly even throughout the year. We're looking at the green bars here, so you can see it does peak in the winter And again, for our Northern Hemisphere friends, winter is in the middle of the year in June, July, August. And during the summer, the rainfall still averages about 40 millimetres per month. Temperatures are relatively mild, although they don't get very cold at all, even in the winter. We're looking at the green line here. Temperatures bottom out at about 8 degrees to 12 degrees, and during the summer they're about 14 to 20 degrees average daytime temperatures. Now, this particular farm realised that they had a problem with their calf rearing, reaching average daily gains, and so they asked us to conduct some efficacy testing. We looked at doing conventional fecal egg count reduction tests, but the starting worm egg counts we felt were too low to warrant doing them. In fact, the World Association for the Advancement of Veterinary Parasitology guidelines do require that you start off with a fairly high worm egg count. That's 200 eggs per gram, 15 animals per group, 15 untreated controls, and it is quite a difficult test to do if you don't have highly motivated staff, which we didn't in this case. So we decided to go for an observational study, and that means that the animals were not left untreated, which could have contributed to poor welfare and growth outcomes for them as well. The other difference to conventional fecal egg count reduction tests was that we used a more sensitive test. This one is called the Mini-FLOTAC, developed at the University of Naples by Professor Giuseppe Cringoli, and they've already done quite a lot of research, both there and with their collaborators, to validate the method and to show that it is a very reliable and speedy method that requires little equipment. There's nothing magic about it though. We could have just used McMaster and repeated the tests until we got a similar limit of quantification, or we could have even used a modified Wisconsin test, but we found that in our lab we've been using this particular slide now for about 2 years, and it is a very, very simple and speedy test. We did a validation against our conventional McMaster testing and found that there was a concordance test of 97%. So we're quite happy with the reliability of the test as well. The study design for this study was, as I mentioned before, an observational study. We had no input into the management input on the farm, or even which anthelmintics were used, except we did request that they refrain from using pour-on anthelmintics as they had been. They took 15 samples from a mob of between 50 and 100 animals, so 15 out of a mob of 50 to 100, and submitted them on day 0, which was treatment day, and then again on day 14. And we were able to compare the two counts and work out which drenches had achieved a reduction of the particular species, because we did a larval culture and matched up the worm egg counts with the larval species identification. So we had a total of 158 pooled samples counted, and the pools were further pooled into mob groups for larval culture, and this is a distribution of the different genera of worms throughout the year. So starting off in May, there were high levels of Cooperia, and same in June, and then we had higher levels of Ostertagia in August and December. And you can see there's Trichostrongylus there in fairly low numbers throughout the year. This slide again shows the percentage of larval composition in the larval cultures, and the Cooperia at the beginning of the trial, the first lot of mobs was quite high, the dominant worm. This slide also shows us the time period when the different treatments were used. So initially it was Cydectin, then Dectomax and Nilverm, and last of all Trifecta Nilworm being an oral levamisole treatment, trifecta being a triple combination of benzimidazole, abamectin and levamisole delivered orally. Now this is the same representation of Ostertagia in larval culture from May to December, and we're particularly interested in Ostertagia because we're noting more reports of type 2 Ostertagia, which cause severe disease and sometimes mortalities in heifers of about the age that these heifers were. And we think that may be related to increasing resistance to MLs, which is the dominant product or the dominant class of anthelmintic used in Australia. Now, even though the actual numbers of Ostertagia weren't particularly high, we do think it's significant because in times of inhibition, up to 90% of the worms are inhibited. So a 30 egg per gram worm egg count may indicate there are up to 60,000 worms in the stomach of the animal. And Trichostrongylus was found in cultures right throughout the year as well. Looking at the overall worm egg counts, you can see that Ostertagia counts rarely rose up towards 100 eggs per gram, but the Cooperia counts were quite a bit higher. And Trichostrongylus, you'll notice that the scale of the y-axis is lower here. They're only about a third of what the counts of the other two worms were. So the average across the entire observation period was 81 eggs per gram, with a variation of 0 through to 620. And these counts probably reflect the fact that we were pooling 5 animals into a single count, so we don't have the same high numbers that we would have seen if we were observing individual animal counts. And then the prevalence of the genera in the counts that we did, you can see Cooperia and Ostertagia were present almost all of the time. Trichostrongylus was present 3/4 of the time. Coming to efficacy, we've got a huge data set on efficacy, and as you can imagine, it's very complex, so it does deserve its own publication, but I'll just present the overall results here. Over 11 tests, with a starting worm egg count of 177 eggs per gram, the Cydectin had an overall efficacy of 27%. During the period when Dectomax was used, the starting worm egg count you can see is quite a bit lower. It's only 45 eggs per gram, but over 11 tests, the efficacy on overall efficacy was 80%. And then when the Dectomax was combined with an oral nilworm treatment, it did appear to have much higher efficacy, but again note at the time that this treatment was used, the starting worm egg count was quite low. This is the benefit of doing repeated tests. We're able to avoid doing a test when you've got only very low worm egg counts. So in summary, we found that the new method of doing before and after worm egg counts using pooled samples and Mini-FLOTAC was a practical way of assessing drench efficacy even on this farm with many management challenges. Pooling samples cuts lab costs but does decrease the actual statistical rigour of doing the test compared to using 15 individual samples. However, Mini-FLOTAC, because it has high sensitivity, low limit of quantification, makes up for that and allows us to do tests even at low starting worm egg counts. And repeated testing allows depth of analysis not possible with a single drench test. So I'd just like to acknowledge Zoetis, who sponsored this project, Van Diemen's Land Company and the lab staff at Dorbits.
Thank you for its presentation.